right angle. Alright, so now we can fill these in. The sine of 30, here's the angle 30. We want opposite of 30 divided by the hypotenuse. What side is opposite 30? 1 divided by the hypotenuse of 2. What's the cosine of 30? We want the side adjacent, not the hypotenuse, but the other side. Cosine is square root of 3 over hypotenuse 2. And tangent from 30 is opposite over opposite over adjacent. 1 is across from 30, side opposite, and adjacent is square root of 3. This, however, has to be rationalized. We never leave square roots in the denominator. So we have learned in math past how to rationalize, which means to get the square root out of the bottom. So we have square root of 3 on the top. Square root of 3 times square root of 3 is 3. And see how quickly it was removed. All right. Notice 30 degrees, if you do a transformation from degrees to radians, this could also say, what is the sine of 30 degrees? If you transform it to radians, is pi over 6. So sine of pi over 6 is also 1/2. Cosine of pi over 6 is square root of 3 over 2. And tangent of pi over 6 is square root of 3 over 2. So this works the same in radian measure as it does in degrees. All right, let's look at another secret that holds. And the other secret is the sine, cosine, and tangent of 60 degrees. If I was doing that one in radians, and you multiplied 60 by pi over 180, you would see that the sine of 60 degrees is pi over 3, and cosine of 60 is pi over 3, and tangent of 60 pi over 3. So 60 degrees and pi over 3 in radians are the same angle. So they're going to have the same sine, cosine, and tangent. So you'll have to be able to tell me the tangent of these special angles in from degrees and from radians. Alright, so let's work it out from 60 now. We're looking at this angle, so side opposite is different than it was from 30, because 60 is in a different position. So sine of 60 is opposite over hypotenuse, so we grab the side opposite of 60 is square root of 3, and hypotenuse is still 2. And cosine of 60 would be side adjacent over hypotenuse, and tangent would be opposite over adjacent. And I don't have to write the 1 because anything divided by 1 is that thing. So there we have the functions, the special functions for sine, cosine, tangent of 60. Alright. Those are the special triangle. That's this one special triangle, and we get another special triangle tonight. So, let me get rid of this. The next special triangle will be created a little differently than the first one, and it will also be memorized. What we're going to start with is a right triangle that is isosceles. So the right angle is up here, and I've tried, isosceles means the two sides, the two legs are equal. So I'm going to just call this 1 and this 1. Since this whole thing is a big right triangle, I'm not going to split it up in any way. I just need to find by Pythagorean what this third side is. So this is the hypotenuse that it's laying on. So I need to use a squared plus b squared equals c squared. So this is the part I'm looking for, the third side. So solving that for c, Or is that showing up? Where is that? It is. So solving that for c, I get 1 plus 1 is 2 equals c squared, and take the square root of both sides. So I get this. These triangles you've seen in geometry class, if not since. So 1 square root of 2 is the special triangle, and the angles in an isosceles triangle have the same angle here as here, because they're across from equal sides, so geometry principle. So this is 90, so what must this angle be if it's the same as this angle, and we'll add to 90 to get 180. Is it not 45? It is. So 45, 45, 90 is the name of this special triangle. And you have to memorize that across from the 45s are 1, and the hypotenuse is the square root of 2. Alright, so let's use that triangle to find the sine of 45, the cosine of 45, and the tangent of 45. So, and that's going to be the same in radians, is pi over 4. That's what 45 degrees is equal to. Cosine pi over 4, same as 45. So you'll have to recognize it when it's in radians and when it's in degrees. So this could be called pi over 4 or 45 degrees. Alright, so let's work through those. The sine of pi over 4 or 45 degrees will come from either side. So I'll have to go from the degrees. Opposite over a hypotenuse. 1 over the square root of 2. Remember how to rationalize. And we get square root of 2 over 2. Cosine of 45 is going to be adjacent over hypotenuse. But that's the same thing. So we get the same 45 and 45 degrees, sine and cosine are the same. And lastly, tangent of 45. Here's 45, so we want opposite over adjacent. 1 over 1 is 1. Alright, so tomorrow when you work on this kind of material, you'll be asked to find sine, cosine, tangent, pi over 6. Sine, cosine, tangent, 30 degrees. Sine, cosine, tangent, 60 degrees. Sine, cosine, tangent, pi over 3. Sine, cosine, tangent.